So verifying, what do we mean by that? That means we're going to take that this left side of the equation and this right side of the equation are equivalent. Well, the difference, one of the big things about verifying is that we are asking ourselves, are they equivalent? We're trying to prove it. We're trying to show it. We can't go across the equal sign, because going across the equal sign would mean, yes, they are equal. Since we don't know that, we can't do that. So there's basically a wall across the equal sign, a big beautiful wall. Oh, sorry. Now we can look across to see what we want to make it look like, but we can't move anything across. So no adding to both sides, subtracting, dividing, can't do any of that. So we just have to change the way things look. To do that, we got to look for those identities. So that half sheet of paper, it's already posted on the wiki also as listed there. So everything's all there. Those are the tools. Those are the things you can use. Okay. Now, no real quick set general rule for it. I guess the best rule, if you want to say a general one, is you'd pick the side which is most complex. And definitely the left side here is more complex. So all we're going to do is work on this side to see if we can match on this side. So can we get this changed around to get cosine of x plus sine squared of x? That's the goal. So it's really just basically a puzzle. Okay, so over here, first of all, again, since I looked over here, which you can look, the right side's only using cosine x and sine x, so I want to change the cotangent of x and tangent of x into using sines and cosines only. So the cosine, by the definition on that sheet, is the cosine of x over sine of x. Now that makes sense. When we did the values, it was x over y. So cosine x, tangent of x is, and this is times, sine of x over cosine x. And now we just follow our simplifying rules. So simplifying would say, if we can do anything inside the parentheses, which is what I would do first. So I still have the sine of x, so nothing here in the first term. Plus, so it's really cosine over 1. Ooh, multiplication? Bye-bye. So the second term turns out to just be sine of x. Now, sine of x times the quantity, the addition, so we're distributing across the addition. So the sine x's cancel. Sine x times sine x. And look over here. It's equal. Woohoo! It's been QB checked. So we just verified that this is equal to this. Okay. What does that mean? If for some reason later down the line we have an identity we know, we could substitute this old gobbledygook with that. Alright. So that's the basic thing. Again, we get good at it by practicing it. And make sure that when you are putting these trig functions, they are followed by an angle. There's something here all along. Next one. Cosine of t minus sine of t, that quantity squared, plus cosine t plus sine of t quantity squared. Is that, again, that's what we're asking, is that equal to 2? Or, more importantly, show it equal to 2. Obviously, this left side has more gobbledygook, more stuff around it, so that's the place we're going to look. Now, be careful when you work on this. You could, I'm not going to stop you from doing this, go ahead and rewrite that first squaring this way. Since it's squared, it's times itself, and multiply that all out and combine like terms, and do the same with the second. Something else I tend to do when I'm looking at these and trying to do this algebra with trig, is instead of thinking cosine t minus sine t, think about it as, what do we get if we just go c minus s squared? Oh, we know what that is. Square the first, so multiply the two together, so it's negative 2cs times 2, and then square the last, because it's a square, it's plus, ta-da, there we go. That's the square of a binomial formula. Well, guess what? We're going to use that to shortcut our whole bunch of work instead of doing this. So square the first, multiply those two together, so you get cosine t times sine t, negative, times 2. So negative minus 2 cosine c times sine of t, and then plus the sine of t squared. Again, just as a reminder, this means the sine of t, whatever that value is, then squared. Just a reminder about that. And now we do the same thing here. Square cosine of t, sorry, multiply times 2, so 2 cosine t sine t, plus square sine of t, so it's sine of t squared. Now you could multiply, again, not going to stop you from multiplying it all out, but we can shrink stuff up. Okay, usually what we try to do is combine like terms and stuff like that, and we could do that. However, the trig does have an advantage. Now granted, these two terms right here, the negative 2 cosine t sine t and the positive 2 cosine c sine t, we're going to combine, and that's 0. However, because I see that identity, that thing twice, and then this is where it comes into play about knowing what those identities are, being able to recognize them in the item as you're writing it. This, by the identity, by that Pythagorean identity, is 1. So is this. 1 plus 1? Oh, looky over here. It matches. So we've just cubic checked it. Car goes wild. More to come on another video.